The topics of this case study are the Rocky Broad River, Hickory Nut Gorge, and the town of Chimney Rock, North Carolina, and how each of these were affected by the events of Hurricane Helene. This unique place offers a stark contrast of towering cliffs enclosing a wild and scenic river that empties into the picturesque reservoir of Lake Lure. It was the site of the water scenes for the film Dirty Dancing. And this small area entices whitewater enthusiasts, kayakers, fly fishermen, hunters, hikers, and backpackers to partake in its beautiful scenery and Class 4 and 5 rapids. All of this changed the week of September 23, 2024, when a massive flooding event devastated the Rocky Broad, Hickory Nut Gorge, and the town of Chimney Rock. We will take a deep dive into the following key factors that have influenced the watershed in this area. We will first discuss the hydrologic cycle's inputs, namely the predecessor rain event and Hurricane Helene. Next, we will discuss the orography of the Blue Ridge Escarpment and its compounding effects on the outflows of the hydrologic cycle and on the geomorphology of the stream and the surrounding mountains. Finally, we will discuss current stream restoration efforts and if they make sense going forward in the area. The hydrologic cycle, more commonly known as the water cycle, has affected this region for millions of years. It has helped shape and carve the gorges and valleys of the Appalachians and is the main driver for erosion in the watershed. The hydrologic inputs were the predecessor rain events that took place 2 days prior to Helene, and then the actual arrival of the hurricane on day 3. The hydrometeorological processes observed during this phenomenon will be studied for years by scientists across multiple disciplines. Leading up to the arrival of Hurricane Helene, a stalled cold front located in eastern Tennessee caused a predecessor rain event that lasted for 2 days. Additionally, the area was located in the upswing of a trough. This promoted a more unstable atmosphere, leading to increased chances of precipitation. Also, a Bermuda high set just off the east coast, allowing low-level moisture to be continuously brought up from the Gulf Stream and the Gulf of Mexico. Compounding these factors were warmer than normal sea surface temperatures in both the Gulf Stream and the Gulf of Mexico. All of these conditions promoted extreme amounts of moisture in the air. This increased moisture reached atmospheric river levels. In fact, measures used to determine the amount of moisture in the atmosphere reached unheard of levels for North America. The integrated vapor transport level reached over 3,000 kilograms per meter per second. Integrated vapor transport is the measure used to determine the strength of atmospheric rivers. Integrated vapor transport is the total mass of water vapor passing over a 1 meter reach of atmosphere per second. The strength of the moisture plume was 1.5 times higher than previously recorded, going all the way back to 1940. For reference, the integrated vapor transport levels were 3 times higher than typical atmospheric rivers that occur along the Pacific Northwest. Another measure used to determine the amount of moisture in the atmosphere is total precipitable water. Total precipitable water is the measure of the depth of a column of water vapor from the surface through the atmosphere if all of that water vapor immediately precipitated as rain. During this event, total precipitable water was measured at over 3.25 inches, or more than 150% of the average maximum value for this event. All of this precipitation translated into an average of 18 inches of rain for the 3-day event, resulting in a 1,000-year flood event. Now that the hydrologic inputs have been described, we will discuss how the unique geology of the area interacted with prodigious amounts of rainfall to create catastrophic damage on the Rocky Broad River and in Chimney Rock. We will then discuss how the topography of the area reshaped the river by using the hydrologic outputs of surface water runoff and groundwater supersaturation. Chimney Rock and the Rocky Broad River are located at the foot of the Blue Ridge Escarpment. This is an area along the eastern edge of the Appalachian Mountains that goes from the North Carolina-South Carolina border up to the Shenandoah Mountains of Virginia. This is an area of orographic lift where there are dramatic increases in elevation over very short distances. It is the interface of the Piedmont Plateau and the Blue Ridge Mountains. The area of the escarpment that influences the events for the Rocky Broad River is unique as it has a southwest to northeast orientation. Why is this important? There is an abrupt 1,500-foot elevation change from the town of Chimney Rock to the top of the escarpment in Hickory Nut Gorge that occurs over the distance of less than 1 mile. In addition, the orientation of the escarpment means that moisture flowing from the Gulf in the south and the Gulf Stream to the east must traverse over the escarpment. So this warm, moist-laden air coming in from both directions must rise above it. As it rises, it cools, condenses, and precipitates rain. This lift intensifies the rain event and makes the atmosphere more unstable, further increasing precipitation. This led to prodigious amounts of rainfall and surface runoff, not only along Hickory Nut Gorge, but all along the escarpment into Virginia. Finally, the total elevation change from the headwaters in the Shenandoah Mountains to the outlet in Chimney Rock is almost 3,000 feet, over a distance of about 30 miles. In addition, the slope of the escarpment is almost vertical. The bedrock is bare in many places, and little vegetation is there to hold the soil in place. This leads to less friction and increased velocities of surface runoff in those areas. As you can see from this heat map, most of the landslides occurred in the upper elevations of the Shenandoah Mountains. This area covers the headwaters of the Rocky Broad River. In the upper elevations of the headwaters, landslides were caused by supersaturated soils lying on severe slopes. In some cases, these debris flows not only stripped the mountainsides of topsoil and vegetation as they came speeding down, but they also scoured the opposite banks as they flowed into the stream channel. Mudlines on trees tens of feet from the surface and scars along stream banks demonstrate the height of the debris flows in these areas. You can also see additional landslides occurred in Hickory Nut Gorge due to the severe slopes of the escarpment and the bare soil conditions. How was the Rocky Broad River affected? Along Hickory Nut Gorge, you can see from pre- and post-Helene satellite images that the channel has been scoured and tons of debris that included vegetation, boulders, gravel, and other sediments have been washed downstream into Lake Lure. The river channel has moved, especially in Chimney Rock. It has undermined US 6474 that goes through the town. Additionally, in Chimney Rock, the river washed out most of the structures adjacent to the channel and several on the opposite side of the street. Finally, along Hickory Nut Gorge, the river washed out the highway in several places all the way upstream to Back Cave, North Carolina. The only good news for the area is the amount of development between the headwaters and Chimney Rock is sparse. The only real development is at the outlet of the Rocky Broad watershed, which is where the town is located. Therefore, almost all of the human toll of debris flows, landslides, and flooding was there. Even though this event cost millions of dollars in economic losses for the town of Chimney Rock and uprooted lives and the community, the river was doing what nature intended, to transport sediment downstream. Over geologic time, flood pulses like this one flush large quantities of rock and sediment downstream, replenishing nutrients and habitat to ecosystems. As we can see through the various illustrations, each pulse moves the stream channel back and forth so the river can mine sediment and transport it away. Now, with more human development near the channel and riparian zones, Other factors now affect the quality of water in the basin. These include human waste and destroyed possessions. Now that the event has passed and recovery has started, what steps are being taken along the Rocky Broad River to restore it? The town of Chimney Rock is still impassable by vehicle. Cleanup of the debris field in Lake Lure has mostly been completed, although there are damaged boats along the beach area of the lake. On my recent trip to the area, I observed earth moving in the channel from Chimney Rock to the Rocky Broads outlet at Lake Lure. From satellite imagery and my observations, it appears as if the Army Corps is trying to move the river channel away from the town and back to the other side of the stream. It looks as if it's being done to allow the town to rebuild on the same ground. This will reverse the meander the river created during the event, but could it cause more harm in the future? Is it wise to move and flatten the meander, considering the Rocky Broad cut a new channel during this event and the resulting meander mirrors the one upstream? Without considering how the river will respond during the next flood pulse, couldn't this create another disaster in the future? Flattening the meander and rechannelizing the river seems to be problematic. It will increase velocities in this area, promulgating more scour. Under normal conditions, this should be okay, but any future flooding events could exacerbate stream bank erosion and scour. In addition, it will require the town to maintain the stream banks in the area, and do they have the staff or funding for this? Wouldn't it be more prudent to allow the river to follow the course it created, move the road to the other bank, and rebuild the town there? If they continue to move forward with rechannelizing, hopefully the Corps will utilize some form of natural channel design, adding rock boulder cross veins and J-hooks in the river. These tools will divert the strongest flows towards the middle of the channel and away from the banks. It probably will not help during massive flood events like what happened during Helene, but it would mitigate smaller flood pulses and protect the stream banks. I hope you enjoyed this video. I would like to offer a special thanks to Dr. Philip Prince of the GeoModels for allowing me to use his DEM and stream channel renderings. Many thanks also goes to NOAA and NASA for providing hydrometeorological data and satellite imagery.